Hey Finxter, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about the Python not operator. So this is one of the basic Python operators, and it's part of my series about all Python operators. And so the short summary of the whole video is Python's not operator returns true if the single operand on which you apply it evaluates to true as well. And this can be like you can apply it to a Boolean value, or you can apply it to an arbitrary object, because in Python all objects are truthy, which means that all objects have an associated truth value. So if you apply the not operator in front of any object, like a Boolean value, or like another object like a list or a string or anything, it actually inverts the associated truthiness of the given object. So I think it's time for an example to actually check this out. So let's open the interactive code shell and we type in the most basic form, the not operator applied on Boolean. So say we have not false, and this evaluates to true, and we have not true evaluates to false. Okay, so this is the most basic usage of the not operator, and also one of the more frequent ones. Yeah, for example, you can store it in a variable like x is, say, 2 is equal to 2, and y is 3 smaller 2, and then you can, for example, apply not x or not y. So some Boolean expressions like this, okay? And but you can also apply the not operator on integer, and if you apply the not operator on an integer value, Python internally converts the integer value to a Boolean value, and which means basically all non-zero integers will evaluate to true per default. So if you convert any non-negative integer to a Boolean value, it is considered to be true. For example, in this case we have minus 99, 99 and 1, for example, all evaluated to true, and except like one integer, which is the integer 0, will evaluate to false. And of course, if you apply therefore the not operator to an integer, it will first convert the integer to a Boolean value, and then it will convert it using this Boolean conversion, which we have already checked out here. So not 0 will result in, you can pause the video and think about this, in true, right? Because 0 will be interpreted as being false, so not false is true. And what happens if you have not minus 99? So this evaluates to false, because minus 99 is considered to be true, so therefore not true is false. Okay, and now let's keep on moving at this pace to the operator overloading problem. So how can we use the not operator on our own custom objects? So for example, we create a class myObject, and it takes a number in the constructor and has like one argument, also any number. It could be like it's really a dummy class now. And say we create 3 types of objects. So we create an object my0, my1 and my99, and pass the respective number into the constructor, so that the attribute points to this number after creation of this object. So for example, if you print my99.number, we should get 99. Good. So now we want to invert those objects, trying to invert those objects. So for example, we simply write a Python statement not my0.number equals not my0. So this is now just pretty print the basically a not string, then an empty space. So per default, if you comma separate the statements in a print, comma separate the values in a print statement, it basically per default adds a space between those two. So we add a space between not and the string representation of my number, which is 0 in this case, and then we have the equal symbol and the result of the operation not my0, which is actually the whole idea of this print statement. So if you run this, it basically prints not 0 equals to false. So this is basically, maybe we should have a better object representation, but for now it's fine, right? We represent each object with our integer value here. So now per default, all objects, so even if we have this, if we apply this same statement to our other custom created objects, all objects will evaluate to false, right? If inverted. Why is that? Because all objects per default evaluate to true. So if you apply the not operator to any object, it evaluates to false, right? Because all objects, it's themselves, so the bool function applied to any custom objects per default evaluates to false. So therefore invert it and you get the true, evaluates to true. Sorry. So all objects per default evaluate to true when applied to the Boolean function, the bool function. And so if you invert them, they of course apply to false. How can we customize this behavior? So for example, the integer value 0 should actually, like intuitively, an empty string or an empty integer value should evaluate to false. I think so. This is just Python convention. So we can basically override the bool method in order to allow our custom behavior for the not and any other logical operator. And we return not, basically we return the bool value of our self.number. So in this case, if self.number is 0, then we will return bool of 0, and bool of 0 will be false. And if the self.number is any other number except 0, then it will return true. So in this case, now we have customized the behavior, and if we run the code now, we see at the bottom here that we have now, like, we have changed the output for in the 0 case, but have the same output in the 1 and 99 case. So in all other cases, we would evaluate not our custom objects to false, because the custom object is considered to be true, and except in one case where our self.number value refers to the integer 0, because now it is considered to be empty. So per default, like the associated Boolean value or truth value to this object would be considered false. So therefore not false is true. So if you invert it using the not keyword. Okay, so you can also apply the not operator on lists, and if you do this, so basically you can apply it on arbitrary objects, as you have seen, even without implementing or overriding the bool function. So of course you can also apply to lists, and the semantics here is that a list is considered to be, so an empty list is considered to be false, whereas a non-empty list like 1, 2, 3 is considered to be true, right? And so therefore you can do the following. You can, for example, check if not, so you can create a list, say list is empty now. Now you can check if not list print hi, else print by, something like this. And now we print hi because the list is considered to be empty, and not list is therefore true. So therefore we check for emptiness of the list, and only if the list is empty, we actually print something like hi, or the list is empty, please fill in some values or so, yeah? So you can therefore, like, this is, many Python experts actually use this type of expression where they don't have like complicated statements like if list equals the empty list or something like this, yeah? So they don't use those things. They use the implicit Boolean conversion of objects to determine the truthiness of the if conditions, and this applies to lists as well. So you can simply check for if a list is empty or not using the default Boolean conversion statement, and then of course applying the not operator to them as well. So this works beautifully, and it works also for strings. So for example, you can check out not hello. So you should be able to figure this out. What is the output of not hello? False. Yeah, so hello is considered to be, it's a non-empty string, therefore it's considered to be true. So we have not true, which is false. So similarly, what if we have not and the empty string? The result is true. Yeah, because the empty string is considered to be false, not false is true, so therefore the output is true in this case. So then the question sometimes is asked, what is the operator precedence? And for example, we can have the following case. This seems to be simple and trivial, right? But here we have like two ways of viewing this expression. So say we have not true and false. So we can either see it as basically not true and false. And this is basically how Python handles it, okay? So it first performs the not true operation, and then it determines the result, which is false, and then it checks false and false, which is false as well. So the output here is false. So these two expressions are basically the same. Python internally uses exactly this operator precedence. So it like implicitly performs this parenthesis operator around the not statement and any operand that follows, like this, in this case, the true operand. Okay, so this is how Python views it. This is a correct way of viewing this expression. But you could also argue, so some people would maybe think that not true and false could also be seen like this, right? But this is not the case, because the not operator takes precedence before or over the and the or operators in Python, like logical and logical or operators. And we have discussed those operators in previous videos, so that I won't dive in detail into these operators. But you can see, like in this case, we have not true and false. This one here, the expression of this sub expression, the result of this sub expression is false. Yeah, because we have a false value here, so the whole expression becomes false as well. And then we invert false, so we obtain true as the result, which is different to the previous two use cases, right? So sometimes it is important to know the operator precedence, and you just can remember, okay, first the not operator has topmost precedence, then you have the and operator, then you have the or operator. Okay, so I think that's enough for today's video. Thanks for watching this video, and see you in the next video. Bye.